Okay guys, let's solve this parallel circuit. As you can see, I have a voltage source of 12 volts and I have 3 different resistors all connected in parallel. So to solve this circuit, what I need to do is solve all of the voltages and currents going through each of these resistors. Now, what we do in a parallel circuit is a little bit different than a series circuit. Meaning what I have to do is recognize the fact that the main feature of this circuit is that I have a a current coming out of my source, and what happens is that current splits off. Okay, and then rejoins actually back here right before after it's spent all of its voltage at the various components. So that's the main feature of the main difference, or the main defining feature when you're looking at a circuit. You can see, oh, this obviously splits off current into 3 different, we call them branches, so I know it's parallel. Let's go about solving this circuit. So one of the more counterintuitive things about parallel circuits is the relationship of voltage across these 3 resistors. So the way I want to think about this is going back to the water analogy. So what I want us to think about is, think about all 3 of these nodes that I've just, 3 of these dots that I've just drawn, think of them as being at the same height. And then if we think of these 3 dots down here as being at different height, they are also at the same height. So actually, if I think of voltage as height, V total, or the way I should put it is the voltage across each of these resistors is equal to the total voltage. If we want to think of it as height, we can think of this as all 3 heights are the same. So in this case, all of our voltages are going to be 12 volts. So let's just write that in. So this now allows us to calculate our current because we can use Ohm's law. Okay, so let's look at current. So current at each of these resistors, well, we're just going to use the relationship V equals IR, or if I rearrange this, I have I equals V divided by R. Now, obviously, we're missing a bit of a step because in order to do this, I need to know what I total is. And in order to know what I total is, I need to know what the total resistance is. So before we circle back to current, what we need to do is look at resistance. So I have to use the formula 1 over R total equals 1 over R1, 2 plus 1 over R3. So this is where I like to use the fraction feature on my calculator, because if I use my calculator in fractions mode, I get that this is 11 over 600. If you choose not to do it in fraction mode, you're going to get 0.01833 repeating. And you can write that as a fraction by writing it over 1, but obviously this form is much more accurate. So what we're going to do is, to find our total, we have to flip our numerator and denominator. So that means we have to do it in whichever form. Okay, so now that we know that our total is 54.55, we are prepared now to look at total current. Okay. Okay, so total current, again, we're going to use Ohm's law. And in this case, we have the total current is a total voltage over total resistance. Okay, so getting back to our circuit diagram, we know that I total is 0.220 amps. So as it comes out of the source, what it's going to do, as soon as it gets to this, what we call junction, it's going to decide how to split up. And really, we don't, we could use proportions here, but we don't want to do that. We want to stick with Ohm's law. So basically, we have to look at what the voltages and what the resistances are between at each of these resistors, and we can use Ohm's law to help us solve. So let's do that now. Okay, so just taking a look back at this circuit, it does make a lot of sense actually if I compare the three currents going through resistor 1, 2, and 3. So the relationship between resistor 1 and resistor 2 is that the resistance is doubled, so the current is halved. And between R1 and R3, we can see the resistance is tripled. So the current is divided by 3. So this all makes sense. But for us to just double check, let's make sure that I total equals I1 plus I2 plus I3. So that's 0. Okay, so we can do that as a final check. All right, so I think the circuit looks good.